solid ice, and I poured this salt on it 30 minutes ago. Okay, and so take an observation, see what on in there, and pass that around. Is we have 2 bags of ice mixed with liquid water. All right. Now I got a food thermometer. We'll take a temperature reading for each one of these bags of ice water, and then we're going to do a little experiment with them to see what happens when we add salt to one of them. So right now we're doing engage, right? We're getting students interested in thinking about these different things we're going to experiment. In both bags of ice up here, one, bag 2, both 32 degrees. Right? Which makes sense because ice melts at 32 degrees. Okay? So I'm going to take one of these, and we'll say this is bag 1 in the front, bag 2 in the back. I'm going to take one of these, and I'm going to pour this ice cream salt into it. Should be enough. So I'm mixing the salt into the water. It's one of your questions on there. What happens when you mix salt into water? What if you just mix it in just regular liquid water? What happens when you pour salt into water and you stir it around? It dissolves, right? It disappears, right? What's that called when you have different things mixed together evenly? A solution, right? Okay, so it's cold, which makes it a little bit harder for it to dissolve. Things dissolve better in hot water, which is why things get cleaner in hot water. But I'm mixing it up here. This is bag 2. You can go ahead and start answering some of those things. We'll give this a couple minutes, and then we're going to take the temperature and see if there's a difference. Okay? So this would be our experimental group, the one that got the independent variable, right, which is the salt. The dependent variable would be the temperature. Just the one with water and ice, we'll take that temperature. What is it?
31.9.
31.9 degrees for bag 1.
20.1.
20. On ice, it melts rapidly, right? Number 2, what does adding salt to a mixture of ice and water do to the temperature of the mixture? Very clearly, it causes the temperature to start dropping rapidly. So that's why they put salt on the roads. When it's snowing out or there's ice coming down, it forces it to start melting because its freezing point changes now. It would have to be very cold. For this, it had to be below 16 degrees Fahrenheit for the amount of salt I added for that to freeze. Now it does get that cold sometimes, and sometimes the salt doesn't work. Also, the salt they use on roads usually isn't this kind of salt, it's a different kind of salt. All right, anybody know the ingredients to ice cream? Milk, cream, sugar, right? So, yeah, milk, cream, and sugar. And then anything to give it its flavor.
We just gotta pass the test.
Ears of the Mickey Mouse, which is the big oxygen, which likes to hog up all the electrons for itself. So when these get in there, in between the water molecules, they start pulling them apart, which is what causes them to melt. All right, but when it does that, when things melt, you have to put a certain amount of heat into them just beyond the temperature changing. So when it warms up like today, the snow's melting, right? Because it's going above 32 and it's causing it to melt. But while it's doing that, it's taking in extra heat that you don't really know about. That's called the heat of fusion. When you put salt on it, it forces it to melt, which means it has to get that heat from somewhere else. And so where does it get it from? It gets it from the other pieces of ice in there and from the ice cream. So it's sucking the heat out, basically, even though in science nothing sucks. It is taking the heat out of the ice cream mixture, and when you take the heat out of something, you cause it to get colder. Right? So that's why it's dropping the temperature like that.